Hello everyone and welcome to another Science Tutor video. I am your tutor Nathan, and today we will discuss another topic in straight line motion, which is acceleration. Alright, so if you remember, in a previous video we discussed speed and velocity, which are the rates of change of distance and displacement respectively. The quantity we're going to discuss today is acceleration, which is another rate of change physical quantity. Now remember we said that the rate of change of a physical quantity is how the physical quantity varies with time. So if you remember, velocity is equal to the rate of change of displacement, right? Which is how quickly the displacement of an object changes with time. And in equation form, v is equal to s divided by t. Right, so a rate of change is just how quickly the physical quantity varies with time, right, or how it varies with time. Right? For today's example, acceleration is also another rate of change. Right? So it's how quickly something varies with time. And in this case, acceleration is equal to the rate of change of velocity. Right? So acceleration is equal to the rate of change of velocity. In equation form, it is equal to v divided by t. And acceleration has the symbol a, usually lowercase a. Right? Now, you might want to note in some books, you might see this being written as delta v divided by delta t. This triangle thing is delta. It's used to signify a change in whatever physical quantity you're measuring, right? So in this case, delta v is equal to the change in v, and delta t is equal to the change in t. So change in v, change in t. And acceleration is equal to delta v over delta t, the rate of change of velocity. So it's how quickly or slowly the velocity of an object changes. And I'm going to give you an example, as usual. Now, I'm a car person, so I'm going to use this car example to kind of simplify things and get the message across. Suppose you have these two cars, a Subaru Impreza, right? Subaru I for short, and a Toyota Corolla, Toyota C for short. One of the things people talk about when they buy a new car is how quickly you can go from 0 to 60, right? How long your car takes to travel from 0 to 60 miles per hour. Now, I did some research before doing this video, and I found that the Toyota Corolla, 2013 Toyota Corolla, can go from 0 to 60 miles per hour in 7.4 seconds. Right? It's pretty quick. So in 7.4 seconds, you're already traveling at 60 miles per hour. Right? Now, a Subaru Impreza WRX, which is my car by the way, can go from 0 to 60 miles per hour in just 5.6 seconds. Now, without any further questions, which one of these cars do you think has the higher acceleration, the larger acceleration? Remember, acceleration is the rate of change of velocity. In this case, 60 miles per hour, this 0 to 60 is the velocity that we're considering. Have an answer yet? The answer is the Subaru. And the reason is because it takes less time, 5.6 seconds, for it to reach 60 miles per hour than the Toyota Corolla does. So it has a higher acceleration. Why? Because the size the size of the change in velocity takes place in a smaller period of time. So the rate at which the velocity changes is larger for the Subaru than for the Toyota Corolla, right? So acceleration is the rate of change of velocity. Let me give you another example. A car with an initial velocity, which we call v initial, of 20 meters per second accelerates to a final velocity, v final, of 40 meters per second in 2 seconds. Calculate the acceleration of the car. Let me give you a little while to write down this question. You can pause the video. Alright, so they give you that v initial is 20 meters per second, v final is 40 meters per second. So the change in velocity, delta v, is equal to 40 minus 20 meters per second, which is equal to 20 meters per second. They tell you that t, the time that it took for this to happen, is equal to 2 seconds. So the acceleration, a, is equal to 20 meters per second divided by 2 seconds, which gives you 10. And the units now are meters per second divided by second, which is equivalent to units of 10 meters per second squared. Right? So, and I want you to take careful note of this. Units for acceleration are meters per second squared. Right? And this is very important, so make careful notes of that. Right? There's something else I want to remind you of before we finish today. Right? And that's that acceleration is the rate of change of velocity. Now, if you remember, we said velocity is a vector quantity. So velocity has both a size or magnitude and direction. Right? So v has both size and direction. Now, acceleration is equal to v over t, or the change in velocity divided by the change in time. Now, the change in velocity, this delta v, can either be a change in magnitude or a change in direction. Alright? So, delta v can be a change in magnitude of v or the direction of v. Alright? So if any one of those changes, then you have an acceleration. If the size changes, then you have an acceleration. And if the direction of v changes, you also have an acceleration. Just to bring this message across, I don't know if any of you have been in a car traveling quickly around the corner, and notice if the driver takes the corner sharply, you almost feel like you're being pressed to the opposite side of the car. What happens in that case is that you are accelerating, although your speed has not changed. In other words, you're still traveling at whatever speed the car was going at before you took the corner. The car's direction has changed, and since velocity is composed of both the size and the direction, then once the direction changes, you're accelerating. So you're actually being accelerated towards the opposite side of the car. Alright, so if a car is traveling along a straight line, right, like so, with a constant speed, alright, so the speed is constant. Since the direction of the car is not changing, then the velocity v is also constant, right? The magnitude of v is the same, and the direction of v is also the same. So both of these are constant. But imagine what happens if this car now, instead of traveling along a straight line, begins to take a corner, just like how I described earlier. Right? When it begins to take the corner, it's traveling like so. Right? Where it is now, its velocity is directed along the path it's going. When it moves forwards a little further, its velocity will be directed at an angle to the path like this. And when it moves on a little further, its velocity will be directed like that. As it moves around the corner, the direction that it's traveling in changes. Even if the speed is the same, in other words, the magnitude of how quickly it's moving is the same. Once the direction changes, then the velocity changes. So v is changing. Alright? And so once an object is no longer traveling in a straight line, once it begins to travel along a curve, even if the speed of the object is constant, once the direction changes, then v changes. And that means that you have acceleration. So today we covered acceleration. I want you to make careful notes. Make sure you understand why acceleration can occur even if an object is traveling at constant speed, because acceleration is the rate at which velocity changes, not the rate at which speed changes. And since velocity has both a direction and a magnitude, once either of those changes, then it results in an acceleration. Alright? So stay tuned for the next video. Remember to like and share this video and leave a comment if you found it interesting. Alright? Thanks for watching.